In this lesson, we're going to continue looking at solving rational equations. When we do all of these problems, instead of getting down to, let me get a color. Once we get to this step, this simplifies down into a linear equation where we have an x on one side of our equals and a number on the other, and we can just solve by dividing to get x by itself. When we do this set of problems in this lesson, it's going to, once we get rid of the fractions, it'll simplify down into a quadratic. So the way we go about solving for x will be slightly different, okay? But the initial process is going to be the same. So when we have something that looks like this, and we need to get rid of the denominators, I'm going to multiply by both denominators. So in this case, it's x plus 1 and x minus 1. I'm multiplying this whole equation by both of those factors, okay? So when I multiply this first fraction on the left by x plus 1 times x minus 1, that x plus 1 is going to go away in the denominator, and I'm going to need to multiply this 6, okay, by x minus 1. Okay. If I look at the right, I'm going to have an x minus 1 that gets canceled, okay, when I multiply this in, but I'm going to have an x times an x plus 1 on the right side of my equation, okay? So from here, I can distribute. So my first step is to get rid of my parentheses. So to do that, I'm going to get 6x minus 6 is equal to x squared plus x, okay? Now, this is where, okay, we have a quadratic. Okay, the reason we have a quadratic is because we have an x squared term. Okay, and we want to most likely factor, okay, when doing these problems. And when we factor stuff, or when we factor quadratics, we want our x squared term to be positive. Okay, so the x squared term is on the right side of my equals, and it's positive where it's at. That means I want to leave it there and move everything else to that same side. So that needs to stay, and I need to move this 6x to the other side, and then I need to move that negative 6 by adding 6. So when I do that, I'll have 0 left on the left is equal to x squared. So we can think of this as 1 minus 6 is going to be negative 5x plus 6. Okay, and now this is something that we can factor. So this is where we ask ourselves, okay, what two numbers add to negative 5 and multiply to positive 6? Now, when we think about factoring, remember, we kind of have 4 scenarios. When we have a positive number that we're multiplying to, there's 2 things that could be happening. Either both of our factors have addition, or both of our factors have subtraction, okay? And then to figure it out, we look at this middle term, okay? Because that is negative, okay, that means that both of our factors are going to be negative, okay? So when I think about my values that I'm multiplying to a positive 6. So I can do that, or I can get that by doing negative 1 times negative 6, and also by doing negative 2 times negative 3. Okay, and when I look at that list, negative 2 and negative 3, okay, is the combination that adds to negative 5. Okay, so that is how I'm going to factor this one. So I'm going to write x minus 2 times x minus 3. Okay, and now I'm not done, okay, because I still need to solve this for x. Okay, and as a reminder, we've been doing a few problems like this with the rationals. Okay, to get something to equal 0, either this part equals 0 or this part equals 0. Okay, so we have 2 pieces of our equation, and if one of those pieces is equal to 0, then the whole equation equals 0. Okay, so I set up both of those equations, and then I go to solve. So for this first one, I'm going to add 2 to both sides. That'll make that go away, and I'm going to be left with just an x, and then equals a positive 2. So to get rid of this negative 3, I'm going to add 3. Okay, so negative 3 plus 3 goes to 0. I'm left with just an x equals 3. Okay, now I'm not done, okay, because I do need to do a quick domain check. Okay, so I need to check my domain. So I need to take both of my denominators. So x plus 1 cannot equal 0, and x minus 1 cannot equal 0. And I need to solve these both for x. So when I do that, I get x cannot equal a negative 1. I also get x cannot equal a positive 1. Okay, so if I think about my domain, okay, 2 is not negative 1 or 1, so I'm good with that solution. Same thing, 3 is also a solution. Okay, so that is solving rationals that simplify into quadratics. Okay, so remember, when we're solving with quadratics, we're going to have two solutions most of the time. Okay, and just as a reminder, I say most of the time because the one time we'll have like one solution is if our quadratic looks like this and we just have that min value on that axis at that point, or we could have like imaginary solutions. So say our quadratic looks like that. We don't have any intercepts with our axis, so we have imaginary solutions. So just a quick refresh on quadratics. Okay, but for the problems that we do in this class, we're usually going to have two things, okay, when we get down here at the end. Okay. All right, let's try one on your own. Okay, so this one, notice, is exactly like this problem. Okay, see if you can use this one as a guide to help you through. Okay, so I'm going to kind of do this one in stages with you. So the first question I have for you is, what do we need to multiply this equation by to get rid of the fractions? Okay, and we need to multiply this whole equation by 3x minus 8 times x. Okay, so now from here, take this and I want you to try to simplify this down into a quadratic. So multiply this out, simplify it down into a quadratic, and then we'll talk about the factoring. Okay, so this is what happens when we multiply this one out. So for that first fraction, when we multiply it by our two denominators, the 3x minus 8 goes away, but I do need to multiply it by the x. For that other fraction, we multiply by our factors, the x goes away, but I need to multiply the top of that fraction by 3x minus 8. Okay, when I do that, I get x squared equals negative 6x plus 16. And guys, again, it is right here. Okay, and it's positive. That means everything else has to come to it. Okay, so that negative 6x has to be added over to the other side, and then that plus 16 needs to be subtracted over to the other side to move everything to the left side of my equals. Okay, now I can factor. All right, so see if you can come up with the factoring on your own. All right, so for this one, the factoring, we are figuring out what adds to 6, okay, and multiplies to a negative 16. So for this one, okay, we're multiplying to a negative number. So when we multiply to a negative, that means we have one positive and one negative number, okay? And because we're adding to a positive, that means that the larger number is the positive number. So if I think about my factors for negative 16, I'm going to have 1 and 16, okay, but then the 16 is the larger one, so it's going to be positive, and the 1 will be negative. And then same process, I've got a negative 2 and an 8, okay, and that is the combination that adds to 6. So that is going to be my factored. So now we can factor this and solve for x. So go ahead and solve for x and get my two answers for this one. Okay, so this is the factored form, x minus 2 times x plus 8. Take each of those factors, set them equal to 0, and solve. We get x equals 2, x equals negative 8. We have one more thing to do, which is our domain check. When I do that, okay, I've got x right here. Let me get my highlighter right here. So I set that denominator not equal to 0, okay, and that just is x cannot equal 0. We don't have to simplify anything there. This one we have to add 8, and then we have to divide both sides by 3, so we get x cannot equal 8/3, okay. 2 is not 0, and it's not 8/3, so it's good. Same thing, negative 8 is not 0, and it is not 8/3, so that was also an answer in our solution set. Okay, so that is number 2. Okay, we're going to try another one that has a little bit more going on, okay, because notice we now have something in one of our denominators that has to be factored. Okay, and remember what I said in the last lesson? If we have something like this, y'all, chances are whatever this is right here is my other two factors, so x plus 2 times x plus 3. Okay, and all you have to do is kind of just like double check. Does 2 and, oh wait, there we go. Do these add to 5? And the answer is yes. Okay, same thing. Do they multiply to 6? And the answer is yes. Okay, so that is the factored form, okay, for the x squared plus 5x plus 6. So for this one, when we multiply, we need to just multiply by those two factors, x plus 2 times x plus 3. Okay, so when we go to do that first fraction, we're going to have an x times the x plus 2 is going to cancel out when I multiply, but I'm going to take this x plus 3 and I'm going to multiply it by that x. Okay. The 2 is just going to get canceled. I'm sorry, not the 2. The denominator under the 2 is going to be canceled out completely, okay, because both factors make up that whole mess, okay? This then equals 5 times, okay, the x plus 3 will cancel, but then I need to multiply the 5 by the x plus 2. Okay, so from here, okay, again, same first step, I'm going to go ahead and distribute. So when I do that, I get x squared plus 3x plus 2 is equal to 5x plus 10. Okay. From here, I'm going to subtract the 5x and I'm going to subtract the 10, okay, and move everything to the left. Why am I moving everything to the left? Because the x squared is there, all right, and it's positive where it's at, so we're going to leave it on that side and move everything else to it. So when I simplify this, I get x squared minus 2x minus 8 is equal to 0, okay. And then for this one, I need to figure out what adds to negative 2 and multiplies to negative 8. Okay. And for this one, we have a situation where our larger number is our negative number. Okay, so when I think about my factors, if my larger is negative, I have 1 times negative 8, 2 times negative 4. Okay, that's all my factors. When I look at that list, the ones that add to negative 2 are 2 and negative 4. Okay, so this factors into x plus 2 times x minus 4 equals 0. Okay. From here, I take each of those factors, set them equal to 0, and then I can solve. Okay, so you guys take a second, solve this. Okay, when we solve here, we get x equals negative 2 and x equals positive 4. Okay, now let's look at our domain. Okay, my domain, I've got an x plus 2 cannot equal 0 in the denominator. I also have an x plus 2 cannot equal 0 in the denominator. So if I think about this, I'm going to get x by itself by subtracting. I get x cannot equal negative 3. Okay. For this one, I'm going to subtract 2 from both sides. I get x cannot equal a negative 2. Okay. Now, when I look at my answers that I got, notice I have a problem. Okay, right? 4 is okay. 4 is not negative 2. It's not negative 3. But y'all, we have an issue right here. Okay, so this is actually not part of our solution. Okay, and I'm going to make this easier to see. I'm just going to write it out. That way, if you guys look back at the notes, it's not just crossed through and you're wondering what's there. So that's not a solution, okay, because we have that piece of information right there. We have the fact that x cannot equal 2. That would cause an issue in our graphs, okay? So we actually only have one solution for this one, okay? So x equals 4 is the only solution for this one, All right, so this is a case where we typically get 2 solutions, okay, because we're going to factor and we're going to get 2, but this is that like special case where, oops, one of those actually is not one of our solutions, okay, only half of them are. So we just have the x equals 4 as part of our answer. Okay, so I'll box that one. All right, I'm going to have you guys try one like this where you have something that is factored. So I've already kind of factored it for you, x squared plus 7x plus 10. Okay, so notice the other 2 factors. When you multiply those together, that's what x squared plus 7x plus 10 is. Okay, so figure out what you need to multiply this one by, all right, and then go ahead and work this one out. Okay, so for this one, I'm going to multiply by x plus 2 times x plus 5, my 2 denominators. Okay, when I do that, I get this. Okay, so for the first fraction, okay, when I multiply that up by my 2 denominators, the x plus 2 is going to go away, but I need to do the x times the x plus 5. Okay, for the next fraction, my x plus 5 is going to go away when I multiply those denominators in, but I need to do the 8 times the x plus 2. Okay, and then the x squared plus 7x plus 10, that gets taken care of by both of those factors. Okay, I'm left with just an x minus 16. Okay, so again, because this x squared was positive over here on the left, I moved everything else to the other side once I distributed. Okay, I got x squared plus 12x plus 32 equals 0. Okay, this is a situation where we're multiplying to a positive, so they're either both positive, both negative. We know they're both positive because the number that we're adding to is positive. Okay, so our factors of 32 are 1 and 32, 2 and 16, 4 and 8. Okay, so 4 times 8 gives me 32 and also is the numbers that add to 12. Okay. So then my next part of my work looks something like this. We've got x plus 4 times x plus 8 equals 0. Okay, set each of those factors equal to 0 and then simplify. So I get x cannot equal negative 4, x cannot equal negative 8. Okay. And for this one, when I do check my domain, I'm okay, all right, because I get that x cannot equal negative 2 or negative 5. So the negative 4 and the negative 8 are both solutions here. All right. So we're now going to make our life a little bit easier, okay? This doesn't look too bad in comparison to the last one in terms of the denominators. All right, so we're going to look at this one and we're going to go, okay, what do I need to multiply by to get rid of the denominator? Okay, and the denominator is just the same thing in both cases. It's an x. Okay, so I'm going to multiply this whole thing by x. Now, when I do that, guys, make sure when you do this, you have to distribute the x to every single term. Okay, so what this will look like is it'll look like 3 times x, okay, and then plus 8. That denominator gets canceled out, okay, and then I have an x, and I'm multiplying it by an x, and then I'm subtracting just a 20, because remember that denominator goes away. Okay, now when I simplify this, I get 3x plus 8 is equal to x squared minus 20, okay. Now, the x squared is positive right where it's at. That means everything's going over to that side. Okay, so I'm going to subtract this 3x to move it over, and then I'm going to write it over here, and then I'm going to subtract the 8. Okay, now I wrote the negative 3x over there because I wanted to write the negative 8 under the negative 20. Okay, you didn't need to do that if you didn't want to, but that is just why I said that. Okay, so this gives me x squared. I'm going to write the negative 3x next, okay, because that is just how we need to write it to help us think through how it factors. And then we've got a negative 28. Okay, so for this one, we have a situation, again, where we're going to have the larger number be negative, okay, because we're multiplying to a negative, so that means we have one positive, one negative, but then we're also adding to a negative number. Okay, so that larger number is going to be the negative. So in terms of numbers that multiply to negative 28, we have 1 times negative 28, 2 times a negative 14, oh, oopsies, and then a 4 times a negative 7, okay? And if you look at that list of factors, the ones that add to -3 are the 4 and -7. Okay, so this factors into x plus 4 times x minus 7. Okay, now I'm going to take each of these factors, set them equal to 0, and solve. Okay, so when I do that, I get x is equal to a -4, and then I get x is equal to a positive 7. Okay, now for this one, again, got to check that domain. Okay, my denominator here, the only denominator I have is an x. X cannot equal 0. Okay, I don't have to simplify that at all. -4 is not 0, and neither is 7, so I'm good to go. All right, so my solutions, I do have 2 solutions for this one. Okay, we've got one more, okay, just like that last one, and I want you to try this one. Okay, now remember the trick with these is you have to make sure to multiply the whole numbers, okay, like the 3 here, or not whole numbers, I'm sorry, the terms that aren't fractions, okay, by that common denominator as well. Okay, so make sure that when you multiply this by the denominator, which is x, okay, you multiply the 15, the x, and the 27 by x as well. All right, so take a second and work on this one. Okay, so for this one, we're going to multiply it by 15. We're going to multiply this by x. Okay, when you do that, you get this. Okay, so I need to do the 15 times x. This one, the denominator just goes away. I'm left with just the -35. Okay, and then I've got the 27 times the x and the x times the x. Okay, again, when I'm simplifying, I need to move the things to the side with the x squared if it's positive. So I moved everything over to this side. All right, that gave me x squared plus 12x plus 35. Okay, for this one, for the factoring, all right, you should have got 5 and 7 are the 2 numbers that add to 12 and multiply to 35, okay? When we write that in factored form, we get x plus 5 times x plus 7. Okay, set each factor equal to 0 and solve. We get x equals -5 and x equals -7. In terms of our domain, okay, so we just have an x in the denominator, so x cannot equal 0. All right, -5 is not 0, and neither is -7, so those are both solutions that exist for this equation. Okay, and that is solving rationals that simplify down into quadratics. Okay, and also a really great review, guys, on solving by factoring. Okay, which was, I think, back in like maybe unit 2. I think it was the start of unit 2. Okay, so if you have any questions about any of that, please let me know.